All right, second lesson in slope. Remember that slope is the steepness of a line. We call it the constant rate of change. We call it the rise over the run. So in our first lesson, we found the slope graphically. So in this lesson, we're coming down here and we're going to do the slope given 2 points. And at the end of the lesson, you should be able, when you're given 2 points that lie on the line, to find the slope of that line. If you remember, slope is one of 4 types. Your slope is positive, it rises as it goes to the right. It's negative, that is, it decreases as it goes from left to right. Or that slope is a horizontal line and there are no mountains, no slope there, so it's 0. It has a slope of 0 mountains. Or it's this vertical line here, which is impossible to ski on, therefore it's undefined. We'll talk today. Today we will understand why a vertical line is considered undefined. All right, when we found the slope graphically, we considered the rise over the run. So the vertical change and then the horizontal change. And you remember how to do that. Just wanted to point out what that meant, the graphical slope. And here we go, finding with 2 points. We need a formula, and this is the slope formula. Now, when you're given 2 points, and we call these points 1 and 2, and we have ordered pairs for point 1 and point 2, and we call them x1, y1, and x2, y2. And the formula tells us that we can find the slope by subtracting the y's, which is called the change in the y, and then we subtract the 2 x's, which is called the change in the x. So to do an example, this here, now we cannot, in just a second, I'm going to find this for you graphically as well as with the formula, just to show you that it works both ways. But if we didn't have the actual line here, but only had these 2 points, how would we find the slope? Well, we could go and graph the line, but what if you don't have graph paper? Well, it's just crazy. So let's do this using our formula. We're going to call this point 1, and we're going to call this point 2. So this is x1, y1, x2, and y2. My formula tells me I need to make a ratio. Oh, let me stop here, and all of a sudden we're seeing this m. Now, m is the constant the variable that we use for slope. And I think it has something to do, and I'm not even making this up, but I could be. I could be just imagining it. But I think the m comes from the word mountain. Hey, works for me. Let's run with it. So here we have the slope m is equal to the change in our y. So we're going to take our second y, which is 3, and subtract it from our first y, which is -2. And then we're going to take our second x, which is 2, and subtract it from our first x, which is -8. So here's our ratio business here. So this negative becomes 3 plus 2 over 2 plus 8, which of course is 5 over 10. We need to reduce that just like we did when we were doing these graphically, and that becomes 1/2. So pause the video here, make a note of the slope formula and what it means. Now let's just take a minute and do the rise and run graphically, just to show you that it is indeed going to work out the same. So I'm going to do my rise up here and my run. Now I prefer having my slope step on the top. It doesn't matter. It really doesn't matter. I know that my line's negative. I know my slope is going to be negative. And so here we go. 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which of course is 1/2, and it's positive. So that is my slope. So you can see that I can do it graphically, but I don't always have the graph, so I need to be able to do it given 2 points. Let's do some practice here. All right, so I know I have x1, y1, x2, y2. And by the way, it makes this much difference. That is 0 difference as to which point you call point 1 and which point you call point 2. It makes no difference. So I just chose arbitrarily, but actually I just made it 1 and 2. Remember, my formula is the change in the y's over the change in the x's. 2, 1, 2, 1. All right, so let's get started here. So I have negative 15 minus negative 16 over negative 7 minus 19, which equals a positive 1 over 26. My slope is 1 over 26. Now, graphing that would have been kind of a pain because the line goes up 1 little unit and then over, way over 26 points. That's a lot to count. I'm really glad I have the formula. Let's look at this one. All right, so x1, y1, x2, y2. I'll say 8 minus negative 13 over 17 minus 17, which equals positive 21 over 0. Wait, stop right there. 0 in the denominator? We can't do that. If you were to pick up your handy dandy calculator and do 21 divided by 0, you would get a message that says error. Well, it'd be spelled correctly, but you'd get a message that says error because you are not allowed to divide by 0. Division by 0, guess what, is undefined. Guess what kind of line this is, ladies and gentlemen? This is a vertical line. All right, got it? This is why vertical lines have a slope that is undefined, because it demands that we divide by 0. Can't do that. Third example, x1, y1, x2, y2. Let's do this. Negative 18 minus negative 18 over negative 15 minus 12. That gives us, negative 18 plus 18. Well, this down here is going to be a negative 27, but wait a minute, that on top, that's going to be 0 over negative 27. Does that make it undefined? Well, no. If you put 0 divided by negative 27 in your calculator, guess what you get? 0. While I cannot divide by 0, I can divide into 0. And when I do that, I get 0. Guess what? This is a horizontal line. This one, of course, is a vertical line. So even when you find the slope using 2 points, you will be able to discover the horizontal and the vertical lines. So again, dividing by 0 is not allowed. It's undefined. Dividing into 0 will get you a 0. Pay attention to the signs and your integer operations when you do this, and you will indeed get your slope positive or negative on those examples. This lesson is for our next one, so I'm going to end this here and say this was finding the slope from 2 points. So ask yourself, are you able, given 2 points, to apply the slope formula? Take a minute and write it down in your notebook, and have a great day.